In this video, we're going to determine the derivative, or actually derive the derivative of sine x by using the limit definition of the derivative, as we've done for all of the previous derivations of derivative rules. So f prime of x is going to be the limit as h goes to 0, and you know what I'm going to say, f of x plus h minus f of x over h, and we're going to apply that to the function sine x. So it's the limit as h goes to 0 of sine of x plus h minus sine of x over h. So the question is, what is the sine of x plus h? Recall this formula from trigonometry, that the sine of x plus y is sine x cosine y plus cosine x sine y. And we're going to use that formula on the next slide to rewrite sine x plus h. So we have replaced the sine of x plus h with sine x cosine h plus cosine x sine h, and then of course we're subtracting still sine x and dividing by h. So let's note that in our numerator, this term and this term have a sine x in common, so we can rewrite our numerator as by factoring out the common factor from those two terms, sine x times cosine h times cosine h minus 1 plus cosine x sine h, and that's all divided by h. And let's note further that we can split that into two limits using the fact that a fraction a plus b over c can always be written as a over c plus b over c. So if we split this up into the two different limits, we see that for this right expression right here, we can use the fact that we just learned that the limit as h goes to 0 of sine h over h is 1, and so that gives us the result that we know that we're looking for, cosine x. In this expression, what we need to do is find out what this limit right here is, and so the assumption would be that that limit is 0. So let's work on that on the next blackboard. So this limit right here is one of those 0 over 0 limits, because as h goes to 0, cosine h goes to 1, and so the numerator is 0 and the denominator is 0 as h goes to 0. And so we have to use some algebraic technique to resolve this limit. You are correctly anticipating that, right, that we're multiplying the numerator and denominator by cosine h plus 1, the conjugate of the numerator. And so let's do that. And so we get sine x times the limit as h goes to 0. The numerator, when we multiply it out, gives us cosine squared h minus 1 over h times cosine h plus 1. And we know that from the Pythagorean identity, we know that sine squared h plus cosine squared h equals 1, and if we subtract 1 from both sides and subtract sine x from both sides, we see that an equivalent identity is the negative of sine squared h is cosine squared h minus 1. So this numerator right here is equal to minus sine squared h. And so let's rewrite below. And then let's notice that we can separate this part of it to, again, take advantage of the fact that we know the limit as h goes to 0 of sine h over h is 1. So that's our way to get rid of the h in the denominator, that we can't let h go to 0 in the denominator, but we're able to handle it that way. So let's rewrite once more. So we're going to divide up our limit from over here in this way, and that is going to allow us to resolve the limit, because we know limit as h goes to 0 of sine h over h is 1. We know that for this expression right here, the numerator sine of h as h goes to 0 goes to 0, and the denominator goes to 0 plus 1, and so that term, or that factor, excuse me, is 0, and so what we have then is sine x times 1 times 0, or that this limit. So putting that information in, this part is going to 1, this part is equal to 0, so we have sine x times 1 times 0, or the limit of that term is 0. So if we go back to the previous blackboard and put that information in, we see that all of this part here equals 0, and so we have shown that the limit of or the derivative, excuse me, of sine x is cosine x. So that concludes this video. Actually, let's wrap it up by itself on as a conclusion. So if f of x is sine x, what we just showed is that f prime of x is cosine x.